Here we are again with our favorite subject, math. Today's lesson is 1.4, the square root function. The square root function is f of x equals the square root of x. So if we were to make a table of values and put in some values for x, obviously the square root of 0 is 0. The square root of 4 is 2. The square root of 16 is 4. So we can plot those values on a graph. Now, we can't put a negative number in for x. You can't take the square root of -4 and get a real number. Now, in a later math class, you'll deal with square roots of negative numbers. But in the real numbers, the numbers that you've learned so far, you can't take the square root of a negative number and get a real number. So the graph stops at 0. But it continues on to the right. So one of the things we want to do is identify the key features of a graph. A couple of key features are the domain and range. The domain is what can we put in for x. So we said we can't put in negative numbers. We can put in 0. We can put in integers. We can put in fractions. We could take the square root of 1/4. So we can put in any positive number. So the domain is x is greater than or equal to 0. The range is the y values we get from the function. You can see on the graph, the y values are all positive. And so the range is y is greater than or equal to 0. And of course, in our function, f of x is the same as saying y. Another pair of key features are the X-Intercept and the Y-Intercept. The X-Intercept is when y is 0. Well, the X-Intercept is 0, 0. And on this graph, you can see the Y-Intercept when x is 0 is also 0, 0. And another feature is to answer the question, is the graph increasing or decreasing? We read a graph from left to right. As we read from left to right, the y values are going up. So this function is an increasing function. So now, here's something for you to try. Graph p of x equals negative square root of x, and identify the key features. So pause the presentation, make the graph, and identify the key features. The graph of p of x equals negative square root of x looks like a reflection of the parent function f of x equals the positive square root of x. So square root of 4 is 2, and when we put a negative in front of it, the opposite of 2 is -2. So the domain of this graph, again, we can put in any positive value for x, so x is greater than or equal to 0, but the y values are negative values. So the range is p of x, or y, is less than or equal to 0. Again, the x and y intercepts are both 0, 0, and as we read from left to right, the y values are decreasing. So this is a decreasing function. Now try this one. Q of x equals the square root of x over 10. Pause the presentation, draw the graph, and find the key features. The graph of q of x equals the square root of x over 10 looks much like the parent function, but it's a flatter graph. So if I put in a 10 for x, 10 over 10 is 1, and the square root of 1 is 1. So same basic shape, but much flatter. And again, the domain is x is greater than or equal to 0. The range, q of x, or y, is greater than or equal to 0. The x and y intercepts are 0, 0, and the graph is increasing. So now let's add some features to the parent function and see how that changes the graph. If I take the parent function, f of x equals square root of x, and then put a +3 on the end, how does the graph of g of x equals square root of x plus 3 compare to the parent function, f of x equals square root of x? Well, one way we could do this is go to Desmos and use their calculator to graph both of these functions. So if we go to the Desmos calculator, we can enter in the first expression, f of x equals, now where's square root? Down at the bottom, there's a keyboard. So if we open up the keyboard, there's a square root button. We can put square root of x. And there's our parent function. So now we go and add a function. So we're going to add an expression. And we have f of x equals, and again we have the square root of x. But now we're going to put a plus 3 on the end. So there's our new graph. So now we can see that the new graph is 3 units above the original graph. Wherever we go, the new graph is 3 units above the original graph. So putting that 3 on the end, move the graph up 3. So now, how does the graph of g of x equals square root of x plus 3 compare to the graph of f of x equals the square root of x? Putting plus 3 on the outside moved it up 3. Putting plus 3 on the inside, how do you think that's going to move the graph? Well, let's go back to Desmos and see. Instead of the plus 3 on the outside, we're going to put plus 3 on the inside. Now, does that surprise you that we didn't move to the right 3? We moved to the left 3 units. Every point on the new graph is 3 units to the left of the original graph. So that moved to the left 3 units. So now let's see if you can figure out how does each graph compare to its parent function. Another way to say this is how does the graph I'm going to give you, or the function I give you, compare to f of x equals the square root of x. G of x equals the square root of x minus 4. How do you think that's going to compare to f of x? The minus 4 on the end is going to move the graph down 4. If I put p of x equals square root of x minus 10, how do you think that's going to compare to the original graph? Remember, the plus 3 moved it to the left 3. So this minus 10 is going to move it to the right 10. So we have a basic function. F of x equals the square root of x minus h plus k. And those affect the graph. So if I take my function f of x minus h plus k, my basic function, if I have h is 0 and k is 0, we start at 0, 0. But now when I put the h value to some positive number, so I have, for instance, x minus 2, then that moved the graph to the right 2. If I put in a negative number for x, so if I have x minus 1, then, or negative 1, x minus negative 1 would be x plus 1. That moved the graph to the left 1. When k is a positive number, it moves the graph up. When k is a negative number, it moves the graph down. Another thing we may want to find is the average rate of change. So for the function f of x equals the square root of x, how does the average rate of change from x equals 0 to x equals 0.3 compare to the average rate of change from x equals 0.3 to x equals 0.6? So looking at this graph, we're trying to see how does the average rate of change from 0 to 0.3 values for x, how does that average rate of change compare to the rate of change going from the 0.3 to the 0.6. Well, the average rate of change, in order to do that, we want to find first these values. When x is 0, when x is 0.3, when x is 0.6. So we can see on the graph, those values are plotted out. Of course, we could always take a calculator. The square root of 0 is 0. The square root of 0.3 is approximately 0.548. And the square root of 0.6 is approximately 0.775. So when we want to compare the average rate of change, we want to find those key values. Now, the average rate of change is going to be the change in y divided by the change in x. So to go from 0 to 0.3, the y values for 0.3 was 0.548 and for 0 was 0. So the average rate of change, 0.548 minus 0, and the x values, we had 0.3 and 0. We subtract those on the bottom. And so now we can calculate that out, and we get approximately 1.83. So now we can do the same thing. We're going from 0.3 to 0.6. We can see those y values are 0.3 and 0.6. So we're going to subtract those y values for 0.3 and 0.6, and then subtract the x values, and we get approximately 0.757. So comparing the 1.83 and the 0.57, okay, we can see that the 0.757 is greater. And so looking at that rate of change, the average rate of change when x is between 0 and 0.3 is greater than the average rate of change when x is between 0.3 and 0.6. Now, here's something for you to try. For the function, h of x equals the square root of 2x. Find h of 8, h of 10, h of 12, and then find the average rate of change of the function over the interval I'm going to give you. Now, before I give you the interval, pause the presentation and find the approximate values of h of 8, h of 10, and h of 12. The approximate values, h of 8, well, 2 times 8 is 16, square root of 16 is 4. And then using a calculator, h of 10 is approximately 4.47, and h of 12 is approximately 4.90. So now, find the average rate of change for the values of x between 8 and 10. Pause the presentation and find the average rate of change. The average rate of change, okay, h of 8 is 4, h of 10 is 4.47, so we're going to subtract 4.47 minus 4 and over 10 minus 8, which is 2, so the average rate of change is approximately 0.235. Now find the average rate of change for the values of x between 10 and 12. All right, so again, 4.9 minus 4.47 over 12 minus 10 gives us the average rate of change of 0.215. Now, we want to be able to compare functions. So here's a problem. Two plans are being considered to determine the speed of a theme park ride with a circular wall that spins. Plan A is represented by the function with the graph shown. The ride shown in the photo is an example of Plan B. If the ride has a radius of 3 meters, which plan would result in a greater speed for the ride? So now, in plan A, we can see that when the radius is 3 meters, the speed of the graph is 6 meters per second. For plan B, we see that the function, the speed, or f of r, is a function of the radius. So the speed is 5 times the square root of the radius. So for a radius of 3 meters, we would plug in 3 for for r, and f of 3 is 5 times the square root of 3, or approximately 8.7. So for a radius of 3 meters, the speed is 8.7 meters per second. So then we can see that 8.7 is greater than 6. So since 8.7 is greater than 6, plan B has a greater speed for a radius of 3 meters. In summary, we have the general function in standard form, f of x equals the square root of x minus h plus k. The domain of this function is x is greater than or equal to h. The range of this function is y is greater than or equal to k. And the minimum point is hk. H moves the graph left or right. So remember, our function is x minus h. So x minus 5, or something like x plus 4, we have to think in terms of x minus. So this moves the graph to the left 4, because that's x minus negative 4. X minus negative 4 is x plus 4. The square root of x minus 4 moves the graph to the right 4. So that's x minus a positive 4. So x plus moves the graph to the left, x minus moves the graph to the right. The k value moves the graph up or down. So if I put square root of x plus 4, that moves the graph up 4 units. If I put square root of x minus 4, that moves the graph down 4 units. And so our function h of x equals square root of x plus 3 plus 5 will translate that graph from the parent function how? If you said it's translated left 3 and up 5, you are correct. This concludes our lesson for today.